All right, for section 8.2, guys, we're going to talk about special right triangles. For this, if you don't like to use this, you could actually still use SOHCAHTOA if you wanted to, but this is going to help you out a lot, all right? So the first one we're going to talk about is a 45, 45, 90. That means you can use this formula, and you have to memorize them. You have an n on the two legs, and then you have an n square root of 2 for the hypotenuse. If you remember where those go, I'll show you here in a minute on exactly how to use that, and it'll help you out a lot. The second one we're going to talk about is a 30, 60, 90 triangle. One easy way to remember this is think about what's the smallest number here, n, 2n, or n squared to 3. Well, hopefully you know that n is your smallest number, so it needs to be across from your smallest angle, which means you always put n across from 30. Then 2n is always your hypotenuse, and then your leg that is across from the 60 will always be n squared root of 3. All right? If you can remember where to put those, it's very easy to solve these next 4 problems. All right? So let's do example 1 here. We notice it has a 45-degree angle. So if we know that that's a 90-degree angle here, a 45 here, that means this is also 45. So we have a 45, 45, 90. So we can put our n on both legs, and then an n squared root of 2 for the hypotenuse. And we know that's the hypotenuse because it's across from the 90-degree angle. So we know that n equals 14. So then we know if x and n are the same thing, we know that x also equals 14. And then if we want to figure out what y is, we just take whatever n, plug it in there, and write it. So 14 square roots of 2. And that's your answer. These might be decimals sometimes, so make sure that you are prepared to put that in calculator if need be. All right? For number 2, we have a 30 and a 90, which means we also have a 60 because the 3 angles of a triangle add up to 180. So across from the 20 or the 30 is where we always put n. The hypotenuse is always 2n, and then the remaining leg across from the 60 is n square roots of 3. So right now we know that n equals 2. So if I want to figure out what this side is, which we'll call, I guess that's an m, it's hard to tell with the way that it's written there, is 2 times whatever n was. Well, if we know n was 2, we can plug that in, so we get 4. And then if I want to solve for the other side, which we'll call n, again, a little too blurry to read there, we'll call that, we put 2n for n, and we get 2 square roots of 3 for your answer. All right? For 3 and 4, they're the same types of problem, but you're starting with a little different part of it. So again, we have a 45, 45, 90, and the reason we know is because the 3 angles of a triangle add up to 180. So our n's go on both legs, and then our hypotenuse is n square roots of 2. So you'll notice right now we know n square roots of 2 is equal to 8 square roots of 2, and we know if they're on the same, if they both have the same piece, we can cancel it out. So you should know automatically that n equals 8. So if I want to find u and v, well, u and v are both labeled with an n, so we know the answer to both of those is 8. All right? For the last one here, we have a 60, which means this angle up here would be 30 because the 3 angles of a triangle add up to 180. We label it properly. Across from the 30 goes n. Hypotenuse is 2n. And then our remaining side across from the 60 is n square roots of 3. So right now, you should know that if n square roots of 3 equals 5 square roots of 3, then n has to equal 5. So now we can solve for x and we can solve for y. X is that hypotenuse, so we take 2 and multiply it by whatever n was, so 2 times 5, and we get 10. And then for y, that's just n, which would equal 5. All right, there's your notes for 8-2, your special right triangles. But again, if this is kind of difficult for you to get, maybe you could just use SOHCAHTOA instead. It works just as well.